Good afternoon and happy Cinco de Mayo. I have been a little sluggish today. I don't know about y'all, but I am taking a lot longer to get going and I'm not sure what's going on today. But anyways, we're back at it. It's 12:42, so I am a little slower than normal, but I apologize. But we're getting it done. I'm going to go over your homework answers first. I've just recopied them from here onto my graph paper so that we can discuss. 40 and 42 were pretty good. You basically, just to kind of wrap up what we talked about yesterday, you're essentially just going to find the magnitude of your original vector and then divide it by the magnitude. So I didn't show that work on this first one, but technically the magnitude of this first one is 2 units, right? That's how long that vector is. And if you wanted to do Pythagorean theorem, you could, like this. The reason that we don't really have to do that on these is because it is a perfectly vertical vector, and so we can just count 1, 2 units. Okay, so you can also do it with Pythagorean theorem. Once you find the magnitude, you're going to go back and you're going to divide the original problem. Okay, well, 0 divided by 2 is 0, negative 2 divided by 2 is negative 1. So there's my answer in green. I also tried to draw it here. So this is my unit vector. Remember, a unit vector means it's only 1 unit long, all right? And you can see that very clearly, and it's going in the same direction as my original one. So whatever the signs were to begin with, you know, a positive and a negative, that should be the same with your final answer. Okay, so with 42, we're going to take our original 5 and negative 12. Notice I just have them right here in the numerator. So like you're really just going to keep it like that. And then you divide by the magnitude. So I found my magnitude over here and then I scaled it back. All right. So let's do it together with 44. Now 44 is in INJ form instead of component form. So we need to put it in component form first. It'll make it a lot easier for us. So remember, this is just basically your x, and this is just basically your y. And then we have to put a negative here with the 2, okay? Because the 2 is negative in that. So you just basically take away the I and the j, and you put it right into component form. Now, I did the magnitude over here already, and I went ahead and simplified my radical. Root 40 simplifies to 2 root 10. And now I'm going to write my final answer. So v hat is going to be, now I'm going to take my original again, and I'm going to divide by the magnitude. Take my original and divide by the magnitude. Okay, I hear a crying baby in the background. I'm sorry if you hear that. And so now we're going to simplify this fraction here, and then we're going to leave the radical in the denominator, which is an a-okay thing here. These simplify, so we need to hold a 1, and we're done. Okay, so I know it doesn't really look really nice. You just take the original from component form, you divide it by its magnitude, and then simplify. All right, so 46 is also in INJ form instead of component form. So it's going to go like this when we rewrite it. It's going to go, so it's with a I, so that means it's going to be the x part, and then the y part is negative. Okay, if we wanted to graph that, we certainly could. Now let's talk about it. Which direction would that be? So negative 6, 0 would be in the x direction, negative, so it would go, let me use blue. All right, so it's going to go 1, 2, 3, 4, 5, 6 to here, like that. Now that is not a unit vector because it clearly has a magnitude of 6. So the magnitude of W is 6. So we want to go back and we want to divide this by 6. And so our answer, our final answer, W hat, remember you just put the hat when you want to say unit vector, negative 1, 0. Okay, and then you could see here, negative 1, 0 goes in the same direction as our original, but its length is only 1. And then with 54, the way you're going to get it into component form is we're going to do terminal minus initial. So 3 minus 0, and then 6 minus negative 2. You can also sketch this on a graph if you want. Let's see if I can fit it on here. I'll try to do my best to do that. Let's see if I can fit it. So 0 and negative 2 would be here, and then 3 and then 6 1, 2, 3, 1, 2, 3, 4, 5, 6. Okay, so my vector is looking like that. That is clearly not a unit vector, but our component form is 3, 8. Now let's check that, okay? Over 1, 2, 3, up 1, 2, 3, 4, 5, 6, 7, 8. Yes, both positive, okay? So now we need to, I need a new page. Sorry, I didn't leave myself enough room. And so we need to find in order to, oh, I think actually this one only asked us, I forgot. This direction said only write it as INJ. So actually we're done. Well, sort of. Once we get it into this form, we're not scaling it back because that's not what the directions asked us. It just asked us to get it in INJ form. So remember, the 3 is going to go with the I, and the 8 is going to go with the J. And then because they're both positive, I'm going to put a plus between them, and then that's it. Okay, so that's my answer for that last one. Okay? Oh, goodness, buddy. It's nap time. I think he's... Poor guy. Sorry. Sorry, I got distracted there. Okay, so that should go over the homework, and please let me know if there are other questions, okay? All right, so now we're going to go into looking at some vector problems where we're going away from the graph, okay? This is going to be much more like quote-unquote real world. So over the next couple of days, we're going to be doing... we are going to be doing word problems, okay? So don't get intimidated by them. I'm going to really try to show and work through them with you, so hopefully it's not too bad. But before we get going on the word problems, I need to kind of show you some tips that will help you draw these appropriately, and then one method called the tip to tail method that we'll talk about in just a second that is crucial in solving these problems. Okay, so first of all, just to kind of put together what we've talked about already, it's number 1 says, what is the magnitude and direction of AB? So I want everybody to understand, AB is the vector. So this right here is the vector. Now, why do I have this dotted line here? Well, the dotted line is to help us come up with the direction, or how many degrees it is. And that's because that's where 0 degrees starts. Okay, and so 28 degrees helps us understand that this angle is opening up. All right, so magnitude, remember you have to have 2 things. We're going to have a magnitude of 8.5 units. We don't know what that is, here. And then we're going to put at 28 degrees because that's what it opens up at. So we have 8.5 units and then 28 degrees. Okay, so now on number 2, it says, what is the magnitude and direction of RT? So notice it's going down here. Now, I want y'all to think there's a little bit of a trick to this question. A lot of students are going to say 110 degrees, but be very careful. What quadrant would you say this RT is in? To me, I hope you can tell, if you were to think about putting your X and Y axis right here, that's in quadrant 3. So it should be between 180 and 270. So we're going to have to use that 110 to help us, okay? So remember, your angles open this way, counterclockwise, all right? So we know it's 4.5 pounds. That's the force. And now in what direction? Well, if this is 110 degrees down here, we can just do 360 minus 110. I'll also show you another way you can do it, which gives us 250 degrees. Okay? Now, another way you could do it is, if you think about this being a perfectly horizontal line, and that's 110, how much would this be right here? Well, that would be 70, right? Because a straight line makes 180. And so a second way you could think about this is doing 180 degrees plus 70. Now Henry's knocking on my door. All right, so now that's another way to get 250 degrees. Okay, so that's your magnitude and your direction. All right, I'd like for you to try number 3. It is also a tiny bit of a trick with the degrees. I want us to keep it positive because you could say negative degrees, but I want to keep it positive, okay? So I want y'all to try 3. Tell me the magnitude and the direction. Okay, with number 4, here is where we have to learn a new method or a new strategy, okay? When it says the resultant, I know you can barely see that, and it says u plus v. Okay, we have done algebraically how to add vectors. We haven't done it like pictorially or graphically. I honestly skipped part of that with the way I typically would have taught it in class because you and I can't sit down and draw things together. That's kind of difficult. So I'm just going to kind of show you here. So basically you have to do this thing called the tip to tail method. So basically the beginning of one vector needs to be at the end of the other vector. Okay? So we are going to we have to slide, okay, one of these vectors, either v or u, okay? And so I am going to leave the one that's horizontal because I think that's the easiest one. So I want to slide this v over this way. Now, I have to keep it parallel. Now, you can see my drawing's not real good. I'm going to try my best to keep it parallel. There we go. That's a little bit better. Because I don't want to change the magnitude or direction of that V. Well, when I slid this V this way, what else slid with it? This 20 degrees also slid with it, okay? So the 20, if you think about it like this, the 20 degrees was to the right of the V. So the 20 degrees is going to go out here. So I'm going to have to kind of extend this horizontal. Okay? And so now I can like cross out, if you will, this vector because I've redrawn it and the 20. And now this is our vector V. It's literally the same vector. I haven't changed the magnitude. I have not changed the direction. I've just slid it. Okay? And now to sketch the resultant of u plus v, you just connect them. The tip or the beginning of this one, which is here, to the tail or the end of this one. And so that is u plus v. Okay? Now the nice thing is you could slide u up if you wanted to or over and you could still get the same resultant. Okay? So there's like multiple correct ways to do this. I'm just trying to show you what I think is the easiest. All right, let's look at number 5. So it says, sketch the resultant vector of u plus v. Well, first of all, we need to ask ourselves, in order to get the resultant, they have to be tip to tail. So are they tip to tail? And the answer is no, they're tip to tip here because they're like the beginning of them are touching. So we need to slide one of them. So we could slide v this way, or we could slide u that way. Both, actually, there's more than that as well. We could slide u down, or we could slide v this way. There's multiple correct ways, okay? Like I said, I'm going to leave the vertical or horizontal ones and slide the others. So I'm going to slide u in this one, okay? So I'm going to take u that was here, and I'm just going to slide it this way. Now, did I try to, it's not perfect, but let's try again. I'm going to try to make it parallel to the original, and then when I slide that, now this goes away. I've kept it the same length and direction. And then this 115 is also going to slide. So notice it was to the left, so it's going to be out here. Okay? And so now to draw the resultant, I'm going to start at the beginning of my original one, or it doesn't really matter, this one though, and I'm going to go to the end of that one, the tip to the tail. So this is u plus v. Okay? And then with number 6, we're going to do the same thing. They are not tip to tail. I'm going to drag u. That's just what my eye sees first, but you could slide v as well. All right, so I'm going to slide u, and I'm going to make it go right here. And so I'm going to now take that away. So my u is here. The 85 was to the right of that vector, so now the 85 degrees is out here. And then I can take that away, and now I'm going to connect. So does everybody see their tip to tail right here? And so now I'm going to do the beginning of this one to to the end of that one, and now that is my u plus v. Okay, that is called the resultant. You'll hear that word and see that word a good bit. Okay. All right, so for 7, 8, and 9, maybe I'll just do 1 and then y'all can try the other 2. It says, what is the magnitude and direction of the resultant? So it's already been drawn for you, like 4, 5, and 6 were not, but I drew them for you. But 7, 8, and 9 are already drawn. You just have to pick out which one is the resultant. So basically just find the ones that are tip to tail. So like for me, I can see it's here and here. Those are my 2 vectors because they're tip to tail right here. And then the resultant should be the other one, right? So here's my resultant, this 13 units. That's its magnitude. And the direction is, it is opening up 27 degrees. Okay? Maybe I'll do one more. Okay, so then with number 8, we have, okay, let's see. We have one resultant to the other resultant, the tip to tail, and so the other one, the 12, is our resultant. And how many degrees is it? Now, a lot of us are going to want to be tempted to say 17 degrees, but just like we said a moment ago, remember, that is going, the way this angle is, if you were to think about in standard position, this is in quadrant 4. So it needs to go all the way around here. So we're going to do 360 minus 17 degrees. Okay? All right. So I'm just checking my work right now to make sure I didn't make any careless mistakes. That's kind of where my brain is right now. Sorry. And then let's write it in. Okay. And I want y'all to try number 9. Okay, so on this page, y'all are trying 3 and 9. Okay, I think that's good for today. My brain's kind of a little fried. I think I told y'all, just a little sluggish today. And then tomorrow and through the rest of the week, we will, Wednesday, Thursday, and Friday probably, we'll just continue to do word problems. But we'll get there. So I guess today you have a little bit of an easy shot. I only need you to try 3 and 9. Make sure you go back to your homework answers and feel okay with that. And I hope you have a great day.